Next topic is obviously designing the responses. Okay,
Mhm.
so as in APG, when we and not just APG but in the HTTP protocol, as per the HTTP protocol, whenever you make a request, there will always be a response, right? So,
Right.
and when the response comes, in the response, you there will be a status code that is one of the mandatory fields, and status code is very important here because status code tells you, okay, your request was successful or not. Okay, and if
Mm.
it was not successful, then what could have been the cause. Okay, so here so here idea is that with the help of status code and the documentation of API, usually API documentation we prepare in open API specs and publish on portals, right? Either portal or somewhere. The documentation and the status codes and all that should indicate, okay, how to fix the problem. And also there is very important thing is that here we have so many status code as per the HTTP protocol. We have so many status code, we cannot support all those status codes in our responses. It will not be possible at all. Okay, so in order to make sure that we are covering most of the, I mean, covering the bases and providing with most of these things, what we do is we select five or six based on the scenarios, five or six of the status code, okay, in the responses. And we make sure that those are we are consistent. Okay, so that we are consistent with those. Okay, so that's why. So so I mean, and that kind of decision is usually made at the start of the API program. So it is not something that we do later. uh, we make it. Okay, at a very early stage itself we decide, okay, which are status codes, uh, I mean, which status code we want to keep. Okay, and then
Mm.
in every single API that we are developing from now onwards for that company on the organization level, we support only from one of those. We usually don't go beyond that. Okay, so
Okay.
here are some of the status code which are used. So you already might be familiar with them, right? So like 200.
Mhm.
So 200 is what 200 okay
200 is success.
success. Then 400.
0 is 400 is 400, 400.
So 400 actually is a bad request. Okay, so
Okay, 400 is method not allowed, right?
no, no, bad request. 400 is a bad request. So when you are missing very mandatory parameter, okay, or
Mm.
if you are say in case of mobile number you are using alphabets, those kind of things, okay. So when
Okay.
either you are not sending the proper data from the semantics, or you are missing out mandatory parameter, okay,
Mm.
those scenarios you we use yeah.
Okay, 400 bad request, then 401 is I think unauthorized.
Yeah, so whenever your authentication or authorization or API key, those kind of things are not correct. Okay, so then we use 401.
401,
What?
403 is forbidden.
Yeah, so forbidden. Can you tell me when this will come? Forbidden will come in which?
Forbidden is, for example, if the user is authenticated, but
Yeah,
he is not able to access a specific resource for the specific request.
correct.
So then it comes forbidden.
Yes. Now let's say, for example, we have this retail API, correct, for which we got API key and secret, right? Now
Mhm.
using the API key is valid, correct, but
Yeah.
you cannot use the same API key for say another API, let's say a payment API or order API, correct? That will
Mhm.
not be allowed, right? So you cannot have. So it is like access related. So if you do not have access, then you will get a 403 forbidden.
Yeah.
Okay.
Yes. 404 is method not allowed, and 429 is too many requests.
No,
500 is internal
404
server.
is not found, resource not found. 404 not found. It is a very
Yeah,
404 not found. Okay.
so it's not found. Yeah.
Yeah, 404 is resource not found when that resource that someone is requesting that doesn't exist. Okay.
Yes.
That is,
Hitting the wrong URL or endpoint.
yeah, yeah.
And
And then,
421 is too many requests.
yeah, yeah, correct. And 500 is
Internal server error.
internal server. So 500 is like very, very generic. So
Very
500.
generic, it's from the backend, I guess.
Yeah, so usually when something is wrong on the server, so if
Hmm.
anything goes wrong on APG, where you might not know what is wrong here, it might be database. I mean, in APG, some logical error in your program, in your JavaScript code, or any policy, something did not work. Okay, JavaScript code did not work, or policy did not work, or in those kind of things. Okay, or if the backend server might be down or something like this, backend database connectivity, database down, or whatever, any it can be like a number of things. Okay, so usually anything which we don't cover in other status codes. Okay, anything which if we do not cover in other status code, the 500 is the default one. Okay, so 500 is default one. So everything which is not covered in others, that automatically comes under 500. Okay, so that is the idea with this 500 one. Okay,
Yeah.
so then, yeah, these are the same thing. Now there are some more apart from this. So these five six that we gave. So those are very common. But here there are some others which are also not that heavily used, but they are still quite used often. So like 201. Do you know 201 is in which scenario?
201 is success only, but
Yeah, so 201 is created. Okay, so
yeah,
basically
created. Sorry, yes.
when you make a post call, so post call is successful, then it is created. So yeah,
Created. Yes.
everything is successful. So 204,
204.
so 204 is no content. So what happens if your request was successful, but there is no content in the response? We use 20.
Mhm.
Okay,
Okay.
so in now 304 is not modified. Okay,
Hmm.
when client makes a call to server using a if modified things header. Okay, so there is a header
Hmm.
called modified things. So using that, if the client makes a call, response is not modified from the last time, then server can provide a 304 response status with not modified. Okay, so
Okay.
okay. Then, you have 405.
405 is, I think, method not allowed, right?
Yeah, 405
405.
not allowed. So if you are trying a method which is not allowed, it will show you a yeah, it will send you 405. Next is 409.
409 invalid request, I think.
The 409 is conflict. So what happens is someone when you're trying to do a create operation in case of post call,
Okay.
if you are reusing a unique key again. For example, if email ID is unique in the request, you are using the same email ID again. Okay, so
Hmm.
same email ID again or same mobile number again, which might be one of the unique identifier in the database. Okay, so when you are
Hmm.
violating the unique key, then you get 409 conflict. Okay, means that record already exists.
Hmm.
And then we have 503.
503 is 503 server unavailable, I think.
Your 503 are basically unavailable, so it is like a service not available. Yes. So
Yes,
503
server
is a
not
service
available.
not available. So either the server is down or service is down. Then
Yes.
503. So yeah, these are the, yeah. I think- So
Just
now,
give me a moment. Huh? Just give me a moment.
okay, okay.
शीतल भाई, शीतल भाई, थोड़ा आवाज Yeah, Manish, please continue.
Yeah. So here, so now this status code that we have in HTTP status code, the response status code, they have a certain, so every hundreds have certain meaning, right? So for example, 2xx, the 200s, all the 200s will be for success scenario. Okay. 1xx
Hmm.
are the informational, but 1xx never used. 1xx is not a final status. Okay. 1xx
Yeah,
is temporary status in between. So 1xx, you will never see 1xx. The final response status start from 2xx. So yeah, 2xx is for uh, uh, this
success.
all the scenario. 3xx is for redirection, resource moved, not modified, those kind of thing. 4x
Hmm.
is like
Client alert and 5 server mostly
I
from
was
server.
putting on server. Okay, so it is very important to remember. So 4xx basically the API is saying something is wrong from your side, right? Either
Hmm.
you are sending wrong authentication, wrong payload, wrong this or unauthorized access, whatever. Correct. 5xx is like your request is okay. Something went on server. It might be anything. We don't know. It can
Yes.
the server
So
down.
if we encounter any 4 axis error, that means that it is not even reached the backend. It has violated inside the APG proxy only.
Most likely yes. Correct.
Hmm.
Yes. But it depends if APG is doing the payload validation, then it will be on APG. But sometimes backend does the payload validation. So
Yeah.
in those scenarios, the yeah, 4xx also can come from the backend. Okay, so
Oh,
it depends on the scenario. But yeah, many times if
yeah.
APG is doing the basic validations and everything, then most likely yes, it will be APG. Okay.
Understood. Yeah.
Obviously, sometimes we don't automatically pass the backend status code. Sometimes if the requirement is there to pass it, then you can pass. But sometimes you might have to rewrite the status code or status message. Okay, so depending on scenario. Okay, so now here are some examples of a bad responses. So here in this example, there is a get call. Okay, and the response is 400 bad request, and in the payload you get error bad request. So can you, I mean, can you tell me why it might be one of the, I mean, example of a bad response?
Okay. So it's a bad request. 400 bad request. For example, the backend, APG is expecting scenario of a bad request. I just give me a moment to think.
Yeah. So basically here you see the client has made the request. Okay. It is not correct, right? Something is wrong. And we are providing, the server provides 400 bad request response to client. Okay. But this response that we sent, okay, there is a problem with the response. Okay. The response that we are sending, that is not the correct way. There is something, example of a bad response. Okay. So the response has something which we should add. So what do you think that response is, why this is not the correct way to provide a.
Means, for example, if the URL that we are sending something wrong with the syntax
Hmm.
in the URL or something like that, so probably we encounter bad request as a response.
Correct. Now
Right?
the, yeah, yeah, correct. So that is there. But here the response that we sent, response says the error field which says bad request and your 400 bad request is status code.
Hmm.
Okay, but we this is not the correct way to send the response. Okay, the
Right.
response is not the correct. So what can we make to what can we do to make the response a better response? That's what I'm asking.
I didn't get your question actually.
In this response, okay, the response
Uh-huh.
that is not the good way to provide the response. How can we improve the response here? That is what I'm saying.
So we can use some default statement. So why it exactly failed? So we can implement some raise fault or raise fault condition, and we can customize the error response over there, stating that this is the exact reason why it is failing. So for example, it is if it's failing in URL syntax, so we can specify error status code and response over there, something like that.
Yeah, yeah, so we don't have to worry about the APG part, how to implement it. But right now we are only talking about API design. Okay,
Hmm.
what basically, rather than providing just like bad request, so if I'm a
Yes,
client, how would I know what exactly is wrong? Correct.
yes,
You are telling
yes,
that your request is not correct, you have to tell me what should I improve, correct, so that I will tell.
yes,
That is why there is no context for how to repair the request. Here there is no context
mm,
for what is wrong, how to repair, right? So now you can
yes.
provide like it is missing this query parameter, for example, right? And
Mm.
you can give the link to documentation, see the documentation, so person can go and check the document, open API spec on the portal, right? And
Mm.
check and fix it. Okay.
Yeah.
Now another one example is the bad response. Now here this is technically not a wrong. Okay. So now somebody is making a call to get user 123. This 123 doesn't exist. So we are providing 404 not found. Okay.
Yes.
That person is calling on another ID 456. Now this ID exists, but the consumer does not have access. Okay. So consumer does not have access to this ID. So we are going giving 403 forbidden. Okay.
Hmm.
So now this is technically it is not wrong, it is correct, but there is still something wrong with the response. Why? What could be the wrong here in this case?
See, if there is 404 not found, okay, so not found means it doesn't specify what exactly. So we can give an error and a message stating what exactly is not found. Means if he is hitting some request with the slash user 123, so we can mention the message that the specific resource path is not found. You have to see the correct resource path and add something like that. And 403 forbidden means the user is authenticated, but he is not um, authenticated, but this is forbidden means it is not authorized to use this resource. So some messages which states that uh, you are not supposed to, you are not authorized to use this resource, or some link where he can go and check what exactly needs to be corrected, something like that in the message.
No, so here what happens is, I mean here in this response, the thing which is wrong is if you are giving them 403, okay,
Mm.
that is technically it is correct response, but problem with 403 is your consumer might be your consumer will always be a technical person, correct? So what they can do is what they can do usually is they can uh, understand, okay, if I'm getting a 403 means this means that there is something I mean this user ID exists, okay, so they will think, okay, this user ID exists, this means uh, uh, if this user id exists, this means they will try to start using other ways to hack the data. Okay, so
Mm.
because many times the hackers they try with all the random user ids, correct? They
Mm.
will try to find which user id exists. They will try with all the random user ids in the url. Okay, and as long as we give them 404, they will think that, okay, this doesn't exist, so this is not. But as soon as they get 403, okay, so if they get 404, they will not bother because they will know, okay, this doesn't exist. As soon as they get 403, this means, okay, this is a valid user id, okay, and they will try to hack. So in order to
Mm.
prevent the hacking, what we should do is, if even if the user id exists but the consumer does not have access, we should provide a 404 not found, so that we are telling it is not exist, so that if it is a hacker will go away. Okay, so like this. Understood? So
Yeah,
it is from a security point of view that it is technically it is not wrong, but from the security point of view, we need to make sure that, okay, it is there. So yeah, yeah. Now, so this is another very another example of a bad response. What you think is wrong here in this case?
500 server DB error message typical failure querying MySQL at 10.3.4.33. Okay. Error is a database error, that is fine. Message typical failure querying MySQL database at 10.3.4.33. 500 is internal server error. So we can give some generic message, uh, connectivity issue, or unable to connect to the backend.
No, we should never give any such kind of thing. We should always give a standard generic message that, okay,
Mhm.
uh, this is internal server error. Please try again later. Reason
Okay.
is that if you give them anything else, okay, if you give anything else, okay, so what happens is if uh, uh, in any response, first the thumb rule is in any response that you are providing in header, payload, anywhere, you should never provide any platform related information. They should
Hmm.
not know whether you are using APG or Java or this or that, any kind of, from the your gateway up till any all the way till the backend. Okay, they should never know what kind of platform you are using. Okay, so that is
Okay.
very important to remember that. So in that scenario, what you have to do is you have to make sure you are providing a generic message. There should not be any header which tells which server you are using, which platform, which technology you are using, because if they get to know, they will start trying to hack that. Okay, if there are any security vulnerabilities or anything, they will start trying to hack that. Okay, so that is why, so we should never uh, provide uh, any such platform information. What we should do ideally is that you just provide a generic message, just generic message, this one failed, and please try again later. Okay, and what you can do is you can provide some correlation ID like this. Okay, so correlation ID or transaction ID, whatever, so you transaction ID or correlation ID, and that ID should be in your logs also. So when they reach out to the support team, they can send reach out to support team. So based on the log this thing, based on this ID, you can search in the logs, okay, internally, and you can internally find what went wrong, and then you can notify the developer team, like dev team or whatever, or if there was temporary server issue or something, whatever, you can check and you can yeah uh, provide the response. Okay, like this, fix it. So for 500s we should not provide any kind of a platform information. Okay, a generic one will be fine. Okay, because something is wrong on the server, so we should know what is wrong. They don't need to know what is wrong. Okay, like this. So now next move is a pagination thing. Okay, so pagination is something that we use a lot. Okay, so pagination is used when there is a large or unknown number of results. Okay, in a list. So when there are a large number or unknown, then we use pagination. Okay, and all of them are of the same type. So all the results are of the same type. Okay, then we use pagination, and also the response is a result of the query. Okay, so when obviously when you are doing a get call, then only you will get a big responses, correct, usually. So the response should belong to the response should be from a result of a query, basically a get call, any search or filtering. Okay, and all
Hmm.
the we usually, obviously, the response should not be like from response is not combined from multiple entities. Okay, either it will belong to all the orders, all the employees, or that should be of the same type. Okay, so in pagination, usually we use two parameter. One is offset and limit. So offset is like your uh, starting index. For example, if you want say 21 to 30, okay, so offset will be 21. Okay, from the list. So you have 100, you are only getting 10. 21 to 30, and limit is the 10. Limit will be 10. 10 is like I'm getting 10 resources starting from 21, like this. Okay, so limit is the number of resource you are returning, offset is the starting index. Okay, so offset is like, yeah, starting index, limit is number of records. So 21 to 30, offset will be 21, limit will be 10. Okay, so that works properly. However, sometime it is not consistent, because when you are doing a get, at the same time, if there is other system which is adding more data, correct, so your record will not be always be reflecting the latest, correct. So your data will not be consistent, right. So in order to be more consistent in the response, what you should do is we use something called value based paging. So in value based paging, what we do is we provide a last parameter. The parameter name is last. So in the last parameter, we can provide, either we can provide the last UUID from the database. Okay, last unique identifier, the last record ID, means we are telling when we made the call, when we retrieve data from database, this was the last unique identifier. Okay, so either we can use that, or we can provide a timestamp. So we will provide our response is consistent with this timestamp. Okay, and if the in the present time it might not be consistent, but our when we did that database, we received the response at this time. So our data was consistent as per this timestamp. Okay, so that way we are telling the client, okay, uh, when we did the response, this was our either this was the last uh, record ID, last unique identifier in that database, or this was the last time. So accordingly, if they want to refresh it, they can again go from the start. Okay, again they can go from the start and refresh it. Okay, also because pagination will have a very large data, right? And in some time in a single record we can have 10, 15, 20 fields. So in pagination we do not provide all the fields, only 3 or 4 fields, not more than that. Okay, so and then we can provide a link to get the full record. So you can provide a link to get the full record, but usually in the pagination every single entity will have 3 or 4, only subset. Okay, not all of those. So here in the pagination, here is one example. The someone is calling this user API offset 21 and limit 10, means 21 to 30, and you are getting the entity. You only get here, you see the ID, first name, last name. Okay, that's it. And then to get the full user data, if someone want to read the full user data, they can parse this href and then call this API to get the full entity. Okay, so that's why you can get it, the list of entities. And apart from entities, you can provide some information about pagination, like what is offset, what is the number of what is the, yeah, in this thing limit, and what is the total records. And you can provide that last parameter, correct, last parameter. Those kind of things you can provide in pagination object here. Okay, so that way client will get to know, okay, these are the things that is returning and all. So you can ignore this one now. Good. So now, as from this section we understand that for good error responses, a good error response will communicate only what the API developer and the user of the app needs to know. Okay, they will give the developer enough information that will allow the correction of the error. So we should remember that we should give enough information, but we should never give more than enough, because we have the risk of getting hacked, right? So we should provide a message that can be should tell the app user why the request did not work. Okay, and we should also include the information that will allow, especially in case of 500s, in case of 500s and server error, we should include the information that will allow our IT team or support team to debug the issues. Okay, diagnose the issues, and we have to make sure that the errors are consistently formatted. Okay, so that they can be used programmatically, obviously. And then we should always assume that the backdarators will try to call the APIs, because obviously our APIs are, if it is available on internet and provided for third party developers or anything, so there will be people who will try to hack it. So we have to assume that, and always provision make the provisions. And once we provide the response payload structure and the status codes and all, so all those should be consistent. Okay, so payload structure and all, everything should be always be consistent. Okay, so that is very important. So yeah, that's it from that is for this topic. Any questions so far in the REST API design?
No, no, I'm fine.
The most important chapter, not I mean anywhere in the field of APIs on any gateway. Obviously, security is the most important thing, because that is usually the entry point for all the API requests to the organization. Okay, whenever the traffic come to any company for the APIs, so gateways are obviously the first line of defense. So they need to make sure that they are compliant with all the latest security standards and protocol. Okay, so before we understand security, we first to understand what are the security issues. Okay, when we are designing something, what are the things we need to think from the security point of view? What should be the considerations? Okay, so we are uh, so now in terms of security concerns, so these are like very old slides. So as per this slide, in fact, already as of now, um, uh, as of now already API uh, the API abuse is already the most frequent attack vector. Okay, for data breaches for any big enterprise, because everyone is now digital. They will have the APIs and uh, um, I mean digital transformation. Everything is digital and everything. Okay, so because of all these digital transformations and everything, right? We have a lot of time, I mean, um, they try to make sure that if hacking via APIs, they will try to make sure that they are able to make any uh, uh, what you say, intrusions, okay, all the intrusions, and misuse the APIs, okay, to hack the APIs and misuse the data from there, okay. So that is one of the main security problems. Now, before understanding security, let's take a step back and understand what are the type of APIs. On a broad level, on a very high level, we have two kind of APIs. One is public API. A public API is something which is available and discoverable on the internet, okay. And obviously, because it is on internet, it can be accessible from anywhere, so it is more prone to attack. In some cases, however, the public APIs only are read-only APIs. They do not provide any update access or anything, and their data that they provide is non-sensitive data. For example, you want to get the list of districts in a city, or sorry, in a state, right? List of districts in a state, or and any kind of information, or the branches of any bank or anything like this. Those will be more pretty just some basic stuff. So those kind of APIs, obviously they don't have any sensitive information. However, more often or not, more often all uh, uh, sometimes these public APIs, they deal with sensitive information. They provide access to sensitive data, and there is sensitive information involved. So in those scenarios, obviously, uh, we need to make sure the API is secured properly. If we don't make sure about all this, then someone can obviously easily try to hack the API and misuse the data. So we need to make sure when there you are dealing with sensitive information, those APIs have proper security mechanism in place. Now, second type of API is the private API. So private APIs are like so in private API also there are two kind of private APIs. Okay, one is your internal APIs. Okay, so one is your internal API. So this is internal APIs are the APIs which are behind the firewall, which are not available on public at all. Okay, so they are within the network only. But many times people think that, okay, because they are inside the network, we don't have to worry about security. But there can be very risky. It can be very risky, because if by mistake the firewall is breached, if someone breaches the firewall, then if your APIs are not having any security, those can be misused, right? So that is why. So we need to make sure, even if it is internal API, it is not accessible outside, we have to make sure it is having all the security mechanism in place. And second kind of API is the partner APIs, where like the access will be obviously API call will go via internet, but they will have point to point security, like the mutual TLS and all those stuff, right? So it will go through um, internet, but obviously connection will be it will be mutual TLS and transport layer security and all those stuff. So those things will be in place. So those APIs obviously also need to be secured properly. Okay, so this is, yeah. So on a high level, this is all. Uh, you know, these are the two kind of API, and we have to make. But overall conclusion is that regardless of the whatever type of API is there, is it public or private, anything, we have to make sure all the APIs require a very thoughtful uh, consideration on the security point of view. Okay.
Yeah.
So now, next question is, when we have established that everything requires a thoughtful security consideration. Next question is, okay, what are those considerations? Which things we have to consider from security point of view? Okay.
Yeah.
So now, uh, the most common security issues or considerations are, we have to manage the traffic, okay, and prevent denial of service attacks. Okay. Next is the identifying the application, or basically application identity. Next is the user authentication and authorization. We need to make sure the user who is consuming, they are authenticated properly, and their access and all is also valid. Okay. And then we need to also consider the data in the transit. So data that is wired in the transit, that should be considered. And we need to check the injection and database attacks. So any kind of injection attacks or database attacks needs to be handled. and we need to also check the application level DOS attacks. So all the application level DOS attacks, we need to prevent against those. And we also have to make sure data confidentiality is in place. So any sensitive data, or we call it PII data, like personal identifiable information, that is not visible anywhere. And the security compliances are in place, so we need to make sure the compliance is there, so that all the checks, who is doing what and everything, audits and all, monitoring audits, everything is there. And we need to prevent against the bots. So we need to make sure the bot traffic, we are able to identify the bot traffic, and we are able to prevent against the bot traffic. Okay, so APGH can help address all these concerns. Okay, now we will see one by one how APGH helps address these things. So first is the traffic management. So in APG we have rate limiting in place. So obviously excessive traffic can cause the DOS attack, right? So they can try to break either the server down. They can make like a brute force attack. In the brute force, they will make thousands of API call within a second and all. They will try to bring down the server, or some yeah. So in APG we have two kind of rate limiting. One rate limit prevents against those brute force attacks. So that way we can so that will block unwanted client from making the call. So we can it will mitigate the brute force attack. So for that we have a spike arrest policy. Spike arrest policy will limit the traffic. If there is any sudden increase of traffic, APG spike arrest will limit it. And then we have another kind of policy, which is quota policy. So in quota policy we provide a limit to a client. Okay, client application will be given a limit. Okay, so that way we can define the traffic limit for the one each app, and then we can improve the experience for all the other apps. So based on the requirement, based on the business requirement on, we can define the limits based on the apps. And those apps, whatever limit you have set for that app, the limit will be applicable for only that many calls are allowed, okay, within the given time frame. It can be limit by minute or hour or something, some we can do that. Okay, so that's one. Then another traffic management is like IP based restrictions. So we can either whitelist IP or blacklist IP, or IP ranges, not just single IP but range of IPs. So that we can do using access control policy. In access control policies, we can either whitelist or blacklist IP address, and we can allow only from the desired location. Okay. We can Next is the application identity. So in application identity, what happens for only for protected APIs? Okay, we need to make sure our APIs are protected, correct? So the last lab that we did, the last time the lab we did was for verify API key, correct? So that verify API key is nothing but your application identity. So we are identifying the application, right, by API key. So client will provide the API key. We identify the application. We verify, okay, this is the API key having correct product and all, and then we allow the traffic. So that verify API key policy is um, used to implement the application identity. Okay, and then API keys can be if you want to revoke, you can revoke the API keys. APG allows you to do that. Okay. Now next is a user authentication and authorization. So obviously whenever there is a API which needs the user data, so when an API needs a user based information based on some user data is involved in those specific APIs, we need to make sure the user is authenticated and authorized also, and then only they are allowed to access. So for authentication and authorization, there are some internet standard protocols which are there, and APG supports all of them. So for example, you have basic authentication, we have OAuth 2, we have JWT tokens, security, the SAML, all kind of thing APG supports. We will cover all these topics in detail. So this slide is only to give a very high level overview of security
Yeah.
thing. Okay, so we will cover all these things in detail in subsequent slides. So APG supports all these things. And also if there is a custom security there using some time, or providers and all, APG can support integration. So many time people use some ping identity management or something like this and all. So APG allows implementation of those custom security and integrations with all those things. Okay, so those things are there. Now next we have is data in the transit. So during the traffic, API traffic, that when the request is coming and all, right? So data in the transit should be encrypted. So for making sure that data in the transit is encrypted and all, we have a one way and mutual TLS. Both things are there. APG can easily, I mean, in APG we easily implement both of them. Okay, and then for usually from client to APG. Most of the time we use one way TLS, because there can be mobile app and web application, front end applications, which might not have the ability to provide the certificate, right? So that is why we have one way TLS. From client to APG we have one way TLS, and most of the time between APG to backend the recommendation is to have two-way TLS. So both of them, both the client and the backend, sorry, the client and server can identify each other using the certificate. So in that two-way TLS scenario, APG becomes a client because the backend will be the server, like this. Okay, so that's one. So next is the injection and database attacks. So in APG, we can provide a security layer where we can provide do the inspection of the incoming data. So whatever data is incoming, so many times these hackers, okay, they will try to uh, inject some kind of query in the code. For example, very common is a SQL injection is very popular among hackers. SQL injection attack. So for example, if you have a API for login, you have a username and password. So what they will do is in the username they will write admin. In password they will write a query, select star from table where username equal to admin, something like that. And that when you do a matching and all, even if you in your code, if you are not very careful, by mistake it might even allow to log in to your admin, right? So like this. So that's why so that is why, in order to prevent such kind of attacks, so SQL injection attack, script injection attack, Java code injection attack, any kind of injection attacks, APG we have the regular expression protection policy or regex protection policy. So there each of these attacks will have a certain pattern. So what APG does is you can define those patterns. Okay, in an APG, APG will look for those pattern in the request. Okay, in the fields whatever you specify, in those field it will look for those patterns. If it matches the pattern, APG will reject the traffic. Okay, so that is one of the things here. Now we have next is the application level DOS attack. So in APG Edge, we have the policy to detect if there is someone is sending a malformed XML or malformed JSON payload. So sometimes people might try to deliberately manipulate the uh, JSON structure. For example, you are only asking for 5 fields, they might send 50 fields and a lot of garbage fields, garbage values. And if you are expecting a string, they might send array. If you're expecting boolean, they might send string. Manipulate the data type, okay, or structure of the JSON payload or XML payload. Okay, so they will try to break the parser. Eventually in the backend we will have XML parser or JSON parser, right? So they will try to break the parser on the backend, so to induce a service level DOS attack. So in APG we have the JSON threat protection policy, which will detect any kind of malform on unnecessary JSON payload and all. It will work on the structure, so it will check and it will throw error. Okay, if any structure limit is breached. And we also have the same for XML. We have XML threat protection policy. Then we have SOAP message validation policy that can validate the request against any XSD or WSDL and all those stuff. So these kind of policies are available in APG for application level DOS attack. And next is data confidentiality. So obviously we have a lot of regulations and uh, privacy concern for data, especially data with financial sector, right? So you have bank account number, credit card number and all those things. So we don't want to make sure this kind of data is accessible to even our APG team, right? Because these are the client data, and the APG developers or people who are doing the APG work and all, they should not have access to those kind of data. To prevent against those, APG has certain mechanism in place. So first is we have role based access. So not everyone will have access to all the APG traces, debug traces and all those stuff. Very few people will have access. And also what we can do is we can set certain things like, so we can uh, mask the data. So in APG we have something called private variable and data masking. So for back, if we want to use the backend credentials and everything, we can do the data masking for those backend credentials. Okay, and then we can use private variables and we can mask the data. And the data masking also is easily available, so that we can simply uh, in any sensitive information that is not visible on the trace. Data will be there, but just that in the trace and all, it will not be visible. So we can do those kind of things, so that any kind of data doesn't show up in the logs or trace and all those stuff. Okay, so that we can put it there. Next is the compliance thing. So for compliance, we have audit log. APG audit logs will track the behavior of all the APG edge users, which user did what and everything. And we have security reporting also, which is in place. But security reporting is on the public cloud version. It is not on the OPD on the on-premise version. Okay. So here it works on the top of analytics. So it can check for certain policies, proxies, and everything, and they use if they are using correct virtual host or correct information, correct HTTP port or HTTPS, or they are using HTTP, and then they can check the user login API usage. If there is any anomaly in the traffic and all, they will identify and they will report to us. Okay, so the APG admins and all those stuff. So those can be done. Another thing is that the bot detection. So obviously many times, as you might be aware, many people like can write the automated code. Those automated code will act like a consumer and they will try to make API calls, right? So like for example, they can do the data crawling, brute force password attack, DOS attacks. For multiple reasons people can use the bots. So usually within the single API request you cannot, you have to go through the pattern, right? So you have to check and analyze the traffic over the time. Over the certain period of time you will analyze the traffic, and then you will see okay, uh, which is the bot traffic and which is the human traffic and all those stuff, a normal app. So APG has this platform called APG Sense. So you have to purchase a separate license for that. It is not part of APG Edge. Okay, APG has APG Sense that will analyze the APG request. It will detect the patterns and all, and it will flag the suspicious traffic. So it will do the flagging, but then you can block it. So you it will detect and it will report it. Then as a admin, you can block the traffic or you can flag it. Okay, so you can do those kind of things to handle this. So yeah, that's it on the security concerns and the mechanism in APG. Okay. Any questions so far? So this
No,
question.
Manish, once we'll cover it in detail, then probably I might have lot of questions.
Okay, this question usually gets asked a lot in interview in different ways. What are the
Hmm.
security policies you implement on APG? What are the things you have to consider for security and all those stuff? So just this provides a complete picture of that. Okay, what are the different security things you have to think about that, and which are the policies that you implement? Okay, so that on the high level you can at least.
Yeah.
So interview I have seen many times. Yeah, these questions being asked from the security. So yeah. mm, Now we have next is the yeah we just so this is one small topic we will cover, and then we can call it a day to day. So this is like for identity authentication authorization. Okay, so this term we see a lot of time this term is used. Okay, and however uh, uh, people get a lot of time people get confused in this. Okay, so this we need to be clear about what is what, because people often get confused in this term, and obviously all these three terms are used a lot in world of API security. Okay, so first is identity tracking, second is authentication, third is authorization. So what is this? So identity tracking is basically just tracking the usage either by app or the user, basically who is using, right, who is calling, identity of the calling, identifying the caller. Okay, so it is like asking do you have a ticket or not. Okay, so usually identity is tracked by we have either API key, we can think okay this is the API key, or the username. So if it is user based API, you can get the username like this. Okay, and authentication is like validating that app, the consumer or end user, either you validate the consumer app or end user, and then you and then you authenticate them, basically you validate their credentials. Okay, so basically here in authentication we ask can you prove your claim. Okay, can you prove what you claim to be. Okay, so that is in the authentication bit. So we need username password. For machine to machine we use private and public key pair, right, mutual TLS also on the system to system. That is one way. Then authorization is determining what that consumer is allowed, either app or the user, what all things that is allowed to do, and is it doing that or not, or is it crossing the limit. So basically what all things you can do. So in authorization we check do you have access and permission to do this thing or not, basically what all things it is possible for you to do. Okay, so that is there. And then this is tracked using tokens in OR tokens and SAML tokens, right? So these the tokens will have the information of all the access and all. So now identity tracking. So as I said, identity tracking is not concerned with authorizing the access and everything. Okay, it is just tracking the usage by the app or user. Uh, what is yeah, what is being who is the calling, basically identifying the caller. So for
Mhm.
apps, you want to identify the app, the API key is used. So your verify API key policy, that is the identity tracking thing. Okay, that is not authenticating because we are not asking for secret or password, correct? So verify API key is used for identity tracking. So that is one of the ways. Okay, so apps are tracked using their API keys, users are tracked using their username or account number and all those stuff, right? Any user identifier. Okay, and sometimes you want to track the consumer, there can be a user agent, correct, or IP, client IP and all those, so that also we can check for identifying the consumer or caller. Then for authentication is the act of confirming the identity. So here usually we store credentials in some data source, correct, and then when the request come, we read the data from the user and we match the data against the data source. For example, they log into APIGEE itself, right? So APIGEE login and all, we have LDAP. APIGEE is the credentials are stored in LDAP. So you read the APIGEE username password, you validate against the LDAP, and then you provide result, right? Okay, if it is allowed, then you go ahead. If it not, then throw error, correct? So for system level, we have the mutual TLS, the private and public key pair. So for authentication, there are some predefined standards on the internet. We have Active Directory or LDAP, okay, and OpenID Connect also is part of authentication. Okay, so all these standards and protocols are there for authentication. And obviously there is a normal database, based on database and all, you do the normal authentication also, that is possible. Okay, so next is authorization. Authorization is basically the act of granting the right and then act of validating the right. So first you grant the rights, okay, okay, you say okay, these are the things you can do, and then when the actual API call comes or user activity is happening, so when the actual activity happens, then you validate, okay, the permissions, is it within the permissions of the uh, user or entity, okay, or not. Okay, so obviously authorization will be done only authorization will be only after the authentication, right? So it is like a three-step process. Step one is identity. First, you identify who is the caller. Second, you authenticate the caller, that okay, it is a valid caller or not. Okay,
Hmm.
go for authorization where you see, okay, if the caller has the permission to perform this activity or make the API call or not. Okay, so usually the proof of authorization is generally transferred as the tokens. So OAuth2 and SAML are the standard protocols for the authorization. Okay, OAuth2 is used a lot. SAML nowadays no one uses, at least I mean it is very very rare. Okay, and OAuth2 is which is the standard for authorization. So OAuth2 is the authorization framework under which most of the systems work. Okay, now in the common pattern of usage, the way, so if you remember last time we did the lab, like in the lab we provided API key in the header. So API key usually is sent in the header. Then for basic authentication, here is one example. The basic auth headers are set in the basic auth. You have the client ID and secret or username password. You do a base 64 encoding and put it in this format in authorization header. So header will be authorization. In authorization header, you send in the format like basic B capital space and the base 64 encoded username colon password. Okay,
Yeah.
then we have access tokens. So access tokens, again the same authorization header is used. So for access token also the same authorization header is used. However, the value will be like this. So you have the bearer tokens, people use the term bearer token also. So bearer with B capital, bearer space, and the access token, the OR token, that is in here. Okay, so yeah, this is, yeah. So yeah, these are on the identity authentication authorization. So some basic concepts about security and all. Next, we will cover OAuth. So OAuth will start from tomorrow. Okay, OAuth and various grant types of OAuth and everything. Okay, so that will start from tomorrow.
Sure, sure, Manish.
So these two slides are just to set the basic concepts, cover the basic concept and all. Okay.